Okay, thank you for the introduction and welcome. So you're almost done. Last 2 sessions for today. I hope you enjoyed this year's buzzwords so far, and my talk today is going to be something like a little recap of what happened over the last 7 years, because it's 7th Berlin Buzzwords. So thank you already for joining. I wanted to start my talk with a little hands raising. So for whom of you is this the first Berlin Buzzwords? Okay, quite a few. And did any one of you attend the very first Berlin Buzzwords in 2010? 1, 2? Cool. And like something more than twice attending? Okay, also quite a few. So, yeah. I'm Christoph. I'm working as a CDO at MBR Targeting. We're a real-time bidding online advertising company. And I've been attending Berlin Buzzwords since 2012. So I missed the first 2 years, but since then I've been a regular visitor. And I've given my first talk last year. And, well, it came to me that I was really wondering, well, now this conference is about buzzwords, but what were these buzzwords again over the last 10 years? And I realized there were obviously some buzzwords that were really like hot topics in 1 year, and no one ever talked about it again in the next year. And then there were other buzzwords who were like trending and becoming more and more important over the years. So, I don't know, just to mention a few, I put up some logos on this slide. I don't know, is anybody still talking about Apache Mahout? I remember it being a very important topic in 2012 when I joined for the first time. Similar for Apache HBase. On the other hand, we have topics like Flink, which is all over the place this year, for example. But I thought since we're like, it's a tech conference and we're all sort of quantitative people, it should actually be possible to answer this question in a quantitative way. So what were the actual buzzwords 2010 to 2016? Let's try to quantify that. And I think a lot of stuff has happened over the past 7 years that should actually make it fairly easy to analyze that. So my plan for today is to basically scrape the websites of the 7 conferences, which are still available on subdomains under Berlin Buzzwords DE, and then extract and analyze the buzzwords. So, yeah, that's the plan for today. And yeah, sure, I want to do that live. I want to kind of see if I can do it in a scalable manner. And I have something like 30 minutes to do that. So let's see if we can manage. So first step will be scrape the historic websites. So if you want to do web scraping, there are basically 2 options in general. You can either simply scrape everything and then try to filter and make sense out of your content later. This is particularly or I would say this is the approach when you basically don't know yet what you're looking for, and in particular you have no idea about the structure of the content that you will be scraping. Or you can do the more like tailored, targeted way, or like the more manual way. If you already know what you're looking for, then you can basically try to only scrape that content that you're really interested in the first place. I mean, there are, of course, tons of, am I still there? Yeah. Okay, so there are, of course, lots of options that, or open source projects that help you with this. So, I mean, I think one of the most well-known software projects for scraping, which has been there ever since we were talking about Hadoop stuff, is Apache Nudge. It's still in active development. And it's really like probably the first choice if you want to do large-scale web scraping with an open source project. But then there are smaller, more tailored, or like then there's a solution for like this more targeted scraping approach that I found, which is a Python library called Scrapy or Scrapy. I don't know how that's pronounced. So while the nudge one is definitely the huge scalable thing, I think for scraping the Berlin Buzzwords websites, the other one will do as well. So here I'm going to use Scrapy. And it's actually pretty well documented, very nice project. So this is taken from the homepage. And all you need to do basically to run your own scraper is to extend a spider class that Scrapy exposes. And then you specify some start URLs where Scrapy will start. And you specify a parse method that parses the content of this site and tells Scrapy what to do, for example, with the links that are found, if those links shall be followed, and so on and so forth. And then here you can specify a callback of what Scrapy shall do if it visited the link. And let me see. So I've written, can you read that actually? Shall I make it a bit bigger or bigger? Better? Still bigger? Okay. So yeah, all I need to do is define this class or extend the crawl spider class. Then here I basically specify allowed domains, which is basically just to make sure that my crawler doesn't leave the Berlin Buzzwords website. And I specify the start URLs, where I basically explicitly put all the prefixes from 2010 to 2016, which is available under www. Yeah, and then there is some more magic, which I will talk about in a minute. But what it all ends up with is a parse method that parses the HTML content of these sites and emits some data. And as you can already see here, I'm looking for some very particular data. So I'm looking for the title of the page, and I'm particularly looking for the session abstract pages, actually. I'm looking for the content, which is basically the session abstract. And I'm also extracting the speakers of these sessions. And I'm also storing the link, so more about that later. So since that will take a moment, let me just run this in the background. So as you can see, this is the class that I just showed you. And I will now activate my virtual environment, and then I will run this spider. So it comes with a tool called Scrapy. It says run spider. I just have to provide my class, and I can specify an S3 location as an output. Okay. So while I will continue with some slides, hopefully Scrapy will now crawl all the web pages from 2010 to this year in the background and place the results on an S3 bucket. All right. While trying that out, I actually realized that scraping web pages is still quite hard. So if, for example, I realized that the websites from 2010 to 2012 didn't come with a content type header. I mean, you can't read it here, but simply the response header content type is missing. And that makes Scrapy think it's not a web page, but something else, and it will simply not parse it. So one of the additional code that you saw in that Scrapy file was actually a workaround to artificially set this HTTP header for these old web pages. Then another thing which actually wasn't that easy was to identify what page is actually a session abstract page, because I want to restrict myself to the session abstracts in the analysis, and what is not. And I initially thought, well, there is an element with an CSS class, this date display single, and it turns out to be there in 2010 and 11, but not 12 and 13 and so on. So, but there are other fields that actually show that, so figured that out, how to identify a session page. Same for the speaker, how do I get the speaker? Again, is it one field in all the pages? No, apparently technology's changed in the meantime, so I have different selectors for different years. And then as well for the session abstract, it was also hidden in different HTML elements. So let me check how Scrapy is doing. It's still working. Okay. So I have one suggestion to, well, or first of all, I can draw an intermediate conclusion that basically scraping the web is still pretty hard, even in 2016, especially if you're trying to scrape content which is made available in a form that's not very scraper friendly. So actually, it does make sense to structure web pages with proper HTML so that they can, so that actually also machines can understand them. And I think it's quite an impressive job that search engine companies like Google and so on are doing by still being able to somehow make sense out of not so well designed HTML pages. Yeah, let's see if the content is there now. So it isn't. I suggest not to not lose any time. I will simply use a file that I've crawled before. I was expecting myself to take a little longer talking so that Scrapy could finish in the background. But instead, I want to continue with the analysis, and that should be the more interesting part. So to analyze that data, I was actually looking for a suitable solution to do that in a way which can be easily presented. So a few years ago, interactive notebooks came up which allow you to manipulate data and have some sort of distributed computing engine in the background. So you edit your data as if, or you can analyze the data as if it was like on your local machine, but in fact you have an arbitrarily big cluster in the background that does the actual computations. But still you get your results back in a very nice way. And there are some commercial solutions which I just listed here, but there are also very great open source alternatives. Like Jupyter, which was previously known as IPython notebooks, or Zeppelin is a very young and promising project. And if you're intending to use Spark, there's a project called Spark Notebook where you can download a whole bundle which includes Spark and everything else, and you just unzip it and run it, and you have a fully running, local, of course, in that case, Spark Notebook. So, I mean, the drawback of these open source things is, of course, that you have to somehow provide the infrastructure on your own, but it's open source. And for those commercial solutions, they will provide you with the infrastructure, and you basically have a cloud-like pay-per-use pricing, usually. And for my analysis, I made some very arbitrary choice, and I picked Databricks, which is a made by the people behind Apache Spark, and I will now switch over to that. So I will follow the golden rule, and as it's shown in Wikipedia, it says you should always do live coding during conference talks, and I will do that now and hope that internet connection will work. Okay, as you see, Scrapey is still not finished, so I will use the file which I have already scraped. So this is how it looks like. I bet I have to make it bigger again. It's a notebook. You can write commands there. They're executed server-side, and you get the presentation of the results. So all I did so far was preparing it with some import statements, which I will run now. And the first time I run something, I'm being asked if I want to spawn a cluster. And I'm here on the community edition, which will launch some Spark 1.6.1 cluster with 6 gigabytes of RAM. And I think it's all running on AWS. But in the paid version, you can basically spawn arbitrarily big clusters in there. Okay, that's it. Then in the next field, I have my AWS credentials, which I have hidden here. And then this is basically some code which I copied from the Databricks documentation, which shows you how to import your data. I will give it a last try. Oh, Scrapey finished. So after 6 minutes, it was a bit slower than before. Scrapey managed to scrape all the websites from the last 7 years, and it put the stuff into an S3 bucket, bbuzz 2016, as you can see here. And it's simply JSON objects line separated. So I can actually mount this bucket in Databricks, which is what this code does. Well, it throws an exception here because the directory is already mounted. And I can have a look at the contents. So, okay. Seems like I didn't set the AWS credentials correctly, so my data is not there. I will then instead use a different bucket where I have this all years JSON lines file, which I wanted to put into that bucket. Still available. Sorry for that. Okay, so I have my bucket with this file. First thing I want to do is read in that file because I want to work with that data. So I will go ahead and say, or I will use the Spark SQL context here. It's a nice, rather new interface of Spark, which allows you to do SQL-like and also data frame-like operations on your data. And it has a read JSON method, which I can use to read this JSON file. And then I can basically register this data as a temp table, and let's call it bbuzz raw. And then I can go ahead and say display something like SQL context.sql, and then I can type any SQL command and can treat it just like as if it was like a database table. So I can say select star from bbuzz raw, limit 10, something like that. And in fact, it shows me the data. So what I realize here is that apparently in the scraping, it didn't work perfectly well. So I don't only have session pages here, but I apparently also have user pages. So let's maybe look at that in a bit more detail, where content not equals empty. Okay, but now I have, I already see that I have session abstracts here. So maybe some of you saw this learning to rank talk earlier this day. Okay, and now I want to go ahead and really draw some conclusions from this data. So if you want to do natural language processing, I mean, there are, of course, great alternatives for that. So there are natural language processing libraries that help you with tokenizing and cleaning up your string. That would be a little bit overkill for this talk, so I will simply go ahead and just apply some very simple transformations on this text to be able to get some meaningful results out of it. So basically, first thing I want to do is, because I want to count words later and find out which were actually the buzzwords in the years, I will first of all lowercase the contents to not have any problems with case sensitiveness. Well then, as you can see, there are still lots of lots of dots and commas and so on, which are of course also posing some problems when you want to analyze the text. So let's remove that. To not stress your time too much, I will copy some code which does that. So here I have prepared some code which basically all that it does, it runs a regular expression, and it first of all substitutes all multiple white spaces by one white space. And what it does as well is it basically substitutes any character that is not like a number or a letter. It just removes them. And it also removes trailing and leading spaces. And like Spark SQL has a nice, or has a pretty easy way to register user-defined functions. You simply say SQL context register function, and then you can register any arbitrary Python function that you defined here, and you can later apply it in SQL queries. So that's basically what's being done here. So I register that cleaning function, and I use it here in the SQL expression. I can run that again. Okay, as you can see, comparing to here, so you have learning to rank, and then like parentheses and a comma and so on. This now all has been removed. And it already looks much better. So if I would run a word count on that now, I would of course have the problem that all these stop words like off and in and so on and so forth would definitely be the highest ranking words. So I'm going to go ahead and remove stop words. And I also don't want to bore you too much and will copy some more code. So Databricks provides a stop words file in some of their S3 buckets, so I just use that. Can have a look at it. Oh, Mr. Nass. Yes. So here you can see typical list of stop words. And I define another function which will simply remove those stop words. So, like the naive way would be to simply nest these user-defined functions in the Spark SQL expression. But unfortunately, that doesn't work because there is a bug in Spark. It's known and not yet fixed. So unfortunately, I have to register another wrapper, which I called clear all, which will nest my user-defined function. So first of all, it will clean the string. Then second, it will remove the stop words. And I can run this again. And I should already have a much better text that I can now finally analyze. There's another thing which I want to get rid of, and I will also just copy and paste that. It's called lemmatization. So you have plurals and singulars of the same word, and I have a very cheap version here. So I just want to remove all the s's in the end of a word, so that I don't have these as two words. So I don't know where. Oops, companies. That's of course a bad example because it will. Oops, because it will. Where was it? Never mind. You get the picture. So I just don't want to have the plural and singular of the same word being counted as two different words. And then final step, and I promise this is the last one in the preparation phase. And there again, I mean, there are probably, of course, libraries for that help you like detecting that something like big data should not be treated as big and data, and open source should not be treated as open and source, but instead as one token. And I have a very cheap variant of that, which I will simply run. Okay, so finally we should have some rather clean content. And I will now go ahead and from my initially scraped raw content, I will create a new table which contains the cleaned version of it. So I select the link, the speakers, I extract with this impression the year from the link, and I clean the title and the content, and I concatenate title and content into a body which I will now analyze. Oops. Already better, but still, okay, we still have these users pages in here, so we should filter them out as well. And there is another expression for that, fairly simple, which simply says if the link is not like /content or /session, or if the title is something like lunch or coffee break and so on, we don't want to consider this document. Okay, and I finally have a table which contains cleaned and like queryable data, and I can now do word count on that, or I can first of all count the number of documents. So I can I registered my sessions here as a table, and I can simply say I want to group these sessions by year, and I want to count them, and I want to order it by year, and then Databricks gives me this nice visualization, so I can actually see, oh, in 2010 it says it says only 10 sessions, which is not really true. Problem is rather that the website doesn't contain all the sessions anymore. But I checked for the other years that these numbers are actually fairly correct. So 2012 and 14 were the years with the most talks. In 2013, there were indeed a lot less talks, and it's actually fairly stable in the last few years. Okay, that's just talks. I now want to have a look at speakers. So who were the top speakers over the years? So for this, I'm simply going to do some word count, basically. So in my table, I have if you remember, I have a column called speakers. And this column already contains an array because there were some talks where there were multiple speakers. So I'm going to access that here. So I can write, so session is my table. I can write, I want to select the speakers. I want to, flat map that, because this is a Spark data frame, basically it will, when you iterate or when you map over a column, it gives you row objects where you then have to access the field once again. So the field is called speakers, and it's property of this line. Then I do the canonical word count with it. So my flat map basically explodes the speaker arrays, and my map produces the word count pairs, and then I reduce by key. And to transform it back, reduce by key does the actual counting, and to transform it back to a Spark data frame, I create a row object which contains the speaker and the number of talks. And then I have to wrap all of that into a SQL context dot create data frame. And I can order this by number of talks. And I can say ascending false because I want to order it descending. And now the question is, who would you guess was the top speaker of Berlin Buzzwords? Any guesses? Okay, that was obvious, but who are a second? Not bad. So, sessions. In fact, you were quite good. So, first place is Ted Dunning with 9 talks, so more than there were buzzwords, actually. And then Grant, Eric, and Uwe, all of them with 6 talks. I think these numbers are not even really correct because, as I said, some talks from 2010 are missing. So I guess all of them gave a talk in all of the 7 years. Well, and then there's many people also with just 1 talk. Okay, so no big surprises on this end. Now let's look at the buzzwords, because that was my final promise, and I'm running a little bit out of time, so I don't. I will not. I will copy and paste the relevant commands. So, what would you say is the single most buzzword, or the buzzword that happened that appeared the most? Well, it's data. Who would have guessed? And then you have things like Apache and Hadoop and use and so on and so forth. But what I actually was asking in the beginning was, how did that develop over the years? So let me copy and paste some more code to be finally able to look at some graphs. So basically what I've been doing here is word count per year, and we can now actually draw graphs that show us the word counts per year. So are there any particular buzzwords that you're interested in to see the development over the years? Otherwise, I will start with those streaming frameworks. And I will make a plot out of this. How can I? No. Sorry, I have to make this smaller ones. Okay, so that's the relative occurrence of the words storm, spark, and flink. So basically the number of the word count over total count of words over the years. And as you can see, Flink took over Spark this year, at least at Berlin Buzzwords. And that's actually quite a great trend, I would say. Well, it didn't even exist in 2014, and Spark was already there. It's quite obvious that now it's really something people are talking about. Any other things that you're interested in? Kafka? Oh, I can basically add it to this graph, maybe. Okay, Kafka is even more popular than Flink, probably because it always comes in conjunction with it. Let's try batch and streaming. Oh, looks like we're really in the age of streaming now. Okay, anything else? Otherwise, since I'm running a bit out of time, let me conclude. Oops. Okay, I tried it live. It worked kind of. Scalable, well, the analysis part in principle was scalable because you, as I said, you can run an arbitrarily large Spark cluster in the background. In 30 minutes, also kind of. But if I remember what it would have taken me in 2010, I would probably not have even walked through this like classical MapReduce example back then in 30 minutes. So I think it's actually obvious that there were quite some advancements over the last 7 years. And yeah, what were my conclusions? So scraping is still hard, even in 2016. We have the #1 top speaker of Berlin Buzzwords, which is obvious. Some other speakers who apparently really have something important to say every year, so I think that's also quite impressive. Flink seems to be a bigger buzzword than Spark this year. I found that interesting as well. And as I said, we're clearly in the age of streaming now. Well, who would have guessed, but I think it's apparent. So yeah, I hope, or thanks for staying with me so long. I hope I didn't bore you too much and just confirmed and quantified what you had expected before. I will put up all the code on GitHub, and the slides will be online as well, of course. And get in touch on Twitter or catch me after the talk. And I fear we only have time for one more question.
Thanks for that, Christoph. Thanks for that. Do we have questions or comments in the audience? Seems like we are good. Thanks again to Christoph.
Okay, thank you.